This is Group Project 2, Developing a New Number System by Hannah Gilbert, Tyler Sutton, and Lydia Susak. So first, counting in our number system. We used 0, A, B, C, D, and so on and so forth. 0 was 0 units, A was 1 unit, B was 2 units, C was 3 units, D was 4 units, and E was 5 units. Task 2 was symbols for our number system. It was the 0, A, B, C, D, E. Does it work to represent large numbers? There's equal representations of units to our number system. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth can be represented with 0, A, B, C, D, A0, AA, AB, AC, AD, and so on and so forth. 10 is AD, 20 is CB, 30 is E0, 100 is BDD, 200 is ECB, 300 is ABB0, and so if it works on these numbers, it also works on other numbers. And then task 4 was to identify numbers of items in a collection. So using our number system, shown on this slide, there is B0 cookies.
Part 5. Show how operations work. Here is an addition example. The addition problem is A plus B, and the sum of that is C. Over here on the right, we have the dots and boxes representation of the addition problem. Next, we have a subtraction example. The subtraction problem is AD minus AB equals B. And over here on the right, we have a dots and boxes representation of that problem. Next, we have a multiplication example. We chose to look at this as repeated addition. So we have the problem AB times B, and we thought of that as saying AB plus AB, because B is equal to 2 units, and the answer would be BD. And then as we have here, we have the dots and boxes representation of the addition problem, and the answer is BD.
Okay, this is our division example, which is in our number system, represented by the letters A, B, C, D, E, 0. It is DB divided by B, which is equal to BA, because as we've learned about division, if we were to represent our number system with units, D represents 4 units, so we have 4 units in the left box, or in the second place value box from the right. And then we have 2 units, which is what would represent B in the first box, and we're dividing it by B, which again is represented by 2 units. So we were looking to make groups of 2 for every box, and we chose nice numbers that worked out, so we didn't have to carry any place value over. And so there's 2 groups from the first or second place value from the right, and then 1 group for the first place value from the right. So we're left with 2 and 1, which, again, going back to our base system, 2 is represented by B and 1 is represented by A, so we get BA. Our next task is to describe how the set of blocks relate to our number system. So based on the mathematician's blocks, there was a dot block, a line block, a square block, and then like a cube or rectangular prism block. So in terms of our number system, how we related it was we said that the dot block would represent our lowest number system symbol, which would be A. And then for so on. So the next one would be the line represents B, or is represented by B. The square block is represented by C, and the rectangular prism or cube block is represented by D, and so on. So then another block could be made that would represent E. And then maybe a blank block could represent 0. So if we had a block with a dot next to a block with a line, then that is our number in the system would be AB. For our next task, which is looking at the transposition of adjacent digits in our number system, and then subtracting them, is when the adjacent digits of our number, so the numbers in our system, are transposed and then subtracted, the difference is divisible by one less than the base, which we don't necessarily have a term for a base, but in terms of bases, it would be similar to something like base 6. Specifically, in our number system, like as shown in our example, when we do DC minus CD, and we get E, because our system is similar to base 6, we get that the transposed digits, example, when subtracted, we get E, which is what's left over, which is represented by 5 units and is 1 less than the amount of units for our place value limit, which we're trying to avoid using the word base 6 because our base is kind of nameless in this system, but it'd be similar to base 6. And our final task is to describe how it'd be different if we used all letters A through Z of the alphabet in our system. Is that it would be similar to that of a base 27 system because letters A to Z represent 1 to 26 units. Then after we hit Z, we go to the next place value over, starting with A again. That's why it'd be similar to a base 27 system.